So today I want to talk about a real project that we did for GE HealthCare. And usually we don't do this, but I think this is an interesting project and they're doing some excellent work. I just wanted to share how what the real world looks like when it comes to data normalization and what challenges you would face. So let's get into the problem. So GE Healthcare is it's actually a separate company. It used to be part of GE, and in fact, like during the duration of the project, we worked with them for a good amount of time. During our project, they split off into GE Healthcare and GE. So there was this whole transition that happened. But basically, they provide diagnostics. They give you they build MRI machines, CT machines, but they're also big in the oncology space. So they give all of the devices needed for radiotherapy, nuclear medicine, and all of this is like cutting edge stuff, right? Like you need the best possible equipment, and many of these like cost millions. So what they do is, although their main business is selling these devices, they also provide software that people can use to actually like multiply their returns, right? Like so think about a tumor board, for example. Like if you have a patient with a particular cancer, it's very rare. You have a tumor board where people of multiple disciplines come together and they have to discuss and they have to like understand what the best thing to do. And they have a product line here called OncoCare, and we actually helped with this particular product. Now, what OncoCare does is it provides a single pane of glass view of the patient of like with everything oncology related. Now, this is a sidecar application, like it's not replacing your EHR, but it sits on the side of the EHR, and you have your EHR, you can move to OncoCare and you can see all the data points that you care about for cancer. Okay. Now, there is also this guidelines for cancer called NCCN guidelines. So this is, again, it's a non-for-profit organization, and they provide you with a detailed worksheet or like a workflow of what you should do if the patient has something, right? Like, so for example, if your tumor size is more than 5 centimeters and the patient didn't respond to chemotherapy, okay, like you should do this. So they have this very detailed PDFs, and they release this like every year, sometimes even like multiple times a year. Now, what GE Healthcare came to MedBlocks for was specifically to help them convert the NCCN guidelines, which is in the PDF format, to computable guidelines that can be executed against like actual data that's on their platform. So let's talk about a few problems, and like let's first talk about the whole OncoCare application was a sidecar app. So again, like it needed data from somewhere. So it needed data from almost like real time from the EHR and other sources, so that a practitioner can reliably like move away from the EHR, look at OncoCare, and all of their data is in there, right? So this is the primary challenge first, right? Like so as many companies do, they also adopted health data platform within their organization. So you have a data platform where you bring data from all of these different sources, and then you like normalize, you put it in this semantically like meaningful way to your applications, and then you store it somewhere. Now, what is that somewhere, right? So they used a FHIR server. So this is a FHIR health data platform. So there is a FHIR API that you can use to communicate with all of the internal data that GE Healthcare has for that particular deployment. Now, is FHIR the right way to go here? Like there has been a lot said about using FHIR for storage. Now again, the OncoCare application was not the only app. They have this whole Edison platform. There is like so many other applications that are relying on the data in this FHIR server. So I'll just talk about some challenges that you face here, right? So the first thing is that you need to get the data into the platform. Like there's already been a lot of work that's been done before we came in, but we did help them move data from these different formats. Like for example, if you take a simple finding, like the site of a particular lesion. In Epic, you might get it in this particular format. Like in Cerner, you might get it in this other completely different format. And you might have different code systems being used everywhere, right? So what usually you have to do is like you need to normalize this. You need to make this like a little bit more meaningful and then bring it into your platform. But because we were receiving most of this in the FHIR format, uh, and your data platform is also in FHIR. We just like the work that was already done before us. The developers just took all of this data and put it into the FHIR server as is. Okay. Now there is a lot of like problems with this. Then like we also had other formats that we had to map. So we were working with some few research sites, and they were giving us the data format in OMOP. So we had to convert the OMOP data again to FHIR. Now here was the kicker, right? Like the problem here was that we needed as much detail as possible in the health data platform. Because again, like we were doing clinical decision support, we could get all the data points that we could get our hands on. But the US core FHIR profile does not really define and tell you how to model something like staging of cancer, right? It could be an observation, it could be a condition, but they don't really tell you what it should look like. So in essence, we had to make our own decisions on what that data point should look like in the FHIR server. And we actually took a look at the M code FHIR profile, which was specifically for oncology. And then we then saw that there was already a lot of data in US core in the repository, and a lot of other applications were already depending on that format. So we can't like drastically change what the FHIR data points look like. So we just ended up adding a lot of extensions to meet these different workflows. So there were a lot of extensions added to just capture these additional data points that were not documented in US core. So you have all of this data, we like integrated from these different formats. Again, there's a lot more integrations going on. There is like HL7v2, there is CCDA, there is like all of this coming into the data platform. You have a FHIR server serving as your data platform, but we now have different ways of storing the same information, right? So like take for example, something as simple as, okay, like I want to understand what the tumor size is, right? It could be any observation. It could be an observation. Maybe it is a condition. Maybe it's in some diagnostic report hidden somewhere, right? So when we were making the rules, when we were making the rules engine, you had to think of all of these different options. And again, in the end, I can't stress how important terminology is and how important the code system and the value sets are. So even though you have the data in different places in like, okay, this could be either an observation or a condition or like whatever, if you can map that exact entity, right? Like if you're able to map any observation with these particular codes, or any condition with these particular codes, or any other resource with these particular codes, then that means this particular thing is true. Like this thing could be a tumor size of more than 5 centimeters, right? So to establish something simple, like for a clinician, it might just be like, oh, isn't that obvious? Like, why can't we find out if the tumor size is more than 5 centimeters? It's something like that's intrinsically built into their heads, and they can immediately see and like understand, oh, okay, that's the case. They can look at the notes. But when doing it using a computational framework, and you want these clinical decision support to be computational, and you want to explain to them what you did, where you got it from, you need to spread out. You need to find all possible ways that the FHIR server could represent this particular bit of information, right? And again, that's where I really want to talk about this because I think FHIR is really good as a messaging format. You're able to get data from multiple places. You're able to at least like liberate this data, and it comes to you in the FHIR format. But when you're storing it in your normalized data layer, like once you are doing the processing, I think it honestly makes more sense to like semantically normalize this data and then do it at the storage layer, right? So instead of us having to query across 10 different resources and 100 other code systems, if the harmonization step happened while pulling all of this data and like while it was getting stored, then the application could have just queried for one single thing, which is like, hey, is the tumor size more than 5? But again, it still worked, right? Like, if we are able to put it all into this one thing, it's just, I'm just cribbing a little about how FHIR allows for this explosion of complexity at the application. And, you could instead just move that one or two steps forward, and you could have that. Again, like, there's no getting over the complexity. People are going to send you different FHIR flavors, and you are going to have to deal with it. I think it just makes life a little easier if we are able to deal with that harmonization step a little earlier, rather than put everything in the FHIR server together and then do the harmonization at the application level. Because when you do that, every application has to do that, right? Like, so every single application has to have this entity mapped to FHIR. Like, I definitely think there is a mismatch of what the actual domain idea is here, which is tumor size of greater than 5 centimeters, and how you can represent that in FHIR. There are 20 different ways to represent that. There are like 100 different codes that you can use to represent that. So again, like, we did the mapping, and then we are able to map this to like different entities. And then from these entities, of course, we were able to capture the NCCN guidelines, and we were able to provide them with explainable clinical decision support. So again, this is still in the testing phase, and people are like still working on it. The good news is, I think the project overall was successful, and like, I'll probably leave a quick testimony at the end as well of what the people at GE HealthCare thought. But I think overall, what I wanted to discuss in this case study, what we learned is that it's not that hard to build applications, right? It's very easy to build any workflow that you want, maybe even a complex clinical decision support workflow. And again, even for that, we first converted the PDFs into computable guidelines, and then it executed on these guidelines. So people could just author these guidelines anytime. Whenever the PDF changes, you have a team who can just like change it into computable content, and then the clinical decision support engine is able to run this. Now again, like, it's not the first time like we are doing this. We considered other approaches. There is like already FHIR CQL. There is a lot of these other like openEHR GDL, which does this very well. But then for our particular case, we didn't find it expressive enough. So we like basically built our own engine that's able to do this. But the complexity is always at the data harmonization. Okay, like, it's always going to be at the data harmonization and like standardizing these different formats and then putting it into this single data platform. Now, I think it's a really good idea to use a data platform like this when you're building a Sidecar application, because you don't depend immediately on the EHR APIs, but then you have your own source of truth, and then you are able to integrate multiple different layers into this, right? Like, so even if in case of GE, they did very advanced NLP on these text documents or these PDF documents, and they were able to mine these different structured resources automatically out of that. So having that platform really helps. Now, my opinion on using FHIR as this platform is a little mixed, right? Like, it works. You're able to like quickly get all of your data from these different systems into FHIR very fast. And in a sense, yes, you are able to like put everything in here. And maybe, I don't know, like, you might be able to map this into a little bit more meaningful stuff. Maybe again, like using the Medallion architecture or some sort of like ETL step. But FHIR was not meant to do that, right? Like, it's really hard to run these ETL steps within FHIR. Like, if you take a tool like DBT and then use something like Snowflake, it's so much easier to do all of this. But within FHIR, there is still like standards like SQL on FHIR coming up, but it's still like practically not there yet in like doing all of these data transformation steps. So what we ended up doing is, again, like moving the complexity to the application, right? So again, this is another pattern that I'm seeing as well, where because you don't have the same transactional guarantees of a normal database, like a SQL database, you end up re-implementing a lot of this logic at the application level. So overall, I think it was a really great experience working with GE HealthCare, and we have a very detailed case study article. Like, do check that out. I will put a link down below. But overall, I think my stance here is a little mixed. Like, I don't know what the right way to do things are. Maybe, if possible, I would have architected this a little differently, with the data platform being something that we are able to control upfront, and we are able to decide what the different data entities go, instead of just putting everything in FHIR and then hoping that each application is able to map to their own entities inside. So hope that was helpful, and let me know what you think down in the comments below. Have you used FHIR as your data platform? Have you run into any issues, or do you think it's the greatest thing ever? Or like, just let me know. I'll be listening. So thanks again for watching, and I'll see you in the next one.
You guys were a surprising find, right? I was looking for someone who had plug and play FHIR expertise and app development experience, and we also had uh, very raw work, meaning we needed to adjust to a lab environment. How do you bring real world experience into a lab? And that requires a lot of handcrafting for the benefit of a larger development team and customer demos, etc. And I think that was one of the biggest things that you could do to represent the outside world inside the building, and also to leverage on your speed. It's so fast. You could also add value to problem solving. We did not need to tell you. We need the, it wasn't only just our voice, right? You guys brought your own perspective. You solved problems in your own way also, which was very well accepted. So I think it was a good experience, which is also why we are looking at how do we continue doing some more work which related to innovation and fast paced.
Nice.
Good, nice.
Yeah.
Thank you.
Thank you.